All right, hello. Welcome to a new video. Today we're gonna do this problem called, I already solved it, but I just want to showcase, because I'm pretty proud of it. Letter combinations of a phone number. It's a medium problem LeetCode. So yeah, I'll just go ahead and demonstrate to you how I solved this and what my thought process was. As you can see, the first few seconds I already submitted it. So I'm just trying to go through it again. So given a string containing digits from 2 through 9 inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. So a mapping of digits to letters, just like on the telephone buttons is given below. Note that 1 does not map to any letters. And yeah, so we're going to solve this problem. So for input, we're given int or string of numbers named digits. And then for our output, we want to return like a dog is looking at me kind of weird. Like, she think I'm talking to her? Okay, no, she's just looking at me. So, anyways, we're supposed to turn a list of strings. Or I'm gonna call it list of strings. It could be a list of ints, but I guess in the output's a list of string. So, oh yeah, possible combinations of the numbers to letters. So list of strings, res, and then let's read it again. We're given a string of numbers named digits, and we're supposed to return all the possible combinations where the digits they map to a letter. And so one digit can map to 3 or 4 letters, and we're supposed to go through all the combinations of that, right? So I guess to note, no, I guess the question is like, I don't think I think it could matter. But just to make sure, I just want to know of the question. So what is the length of input? And then, um, yeah, I think that's it. And I'm pretty sure that they do need to be in order, but I'll just ask like, do the numbers? Yeah, it doesn't matter. I think that's a stupid question. So what is the length of the input? The length of the input is up to 4. So 0, it can be 0 equal to 0. So min 0, max 4. I always like to say it like that because it makes sense for me. So yeah, and then I think that's all the questions I need to ask. So let's go into some examples, I guess. So with 23, I think I'm going to use this as a good example. Hold up, let me just get an Excalibur. We use 23 as a good example. So like 23, pretty sure it's A, B, C, D, E, F. So A, B, C is for the 2, and 3 is D, E, F. So for the 23, we know that we could go from an A from 23. Oh, so we start with A, right? And then there's also a B. So there's also a B for the 23. I hate how they're not the same size, but and then there's a C. And then from 3 we can go D, E, F. So we can just like do like D, E, F, D, E, F, and then D, E, F. So basically it goes like A, D, A, E, A, F, B, D, B, E, B, F, C, D, E, F. I mean C, D, C, E, then C, F. So yeah, that's pretty much it as an example. So, but we need to return it to a list, but from what I just said, we can just put that all into a list, right? But I'm too lazy. So, yeah. So yeah, it says right here also. So that's cool. Um, so that's pretty much it. As an example. So, let's go ahead and match. We're also using some backtracking, so expect some like recursion, maybe like dot append, that dot pop, etc. Um, and then we're also going to go through a for loop. For loop. We want to iterate through the for loop for every key, for every value in that key. So when I say value in key, my dog's like watching me talk. It's kind of weird. It's like I'm a teacher. She's like watching me talk. It's so strange. Maybe she's trying to understand. But anyways, so for loop. When I say a value in key or key value, I'm referencing to a dictionary or hash map. I'm saying this so we can map the numbers to their map numbers and uh and letters. So for example, like two, it has A, B, C, three has D, F. So when I'm trying to say that the key is equal to the number, the value is equal to a list of letters. So yeah. So that's pretty much it. So let's go make a plan. Let's plan this out before we actually code it. So first off, I want to make like let's call it mapping equal to um, default dict of list, and we're basically gonna have like I said before, right? Where the key is equal to number and value is equal to a list of letters, right? And then we're gonna have a res equal to empty list. That's gonna restore our all of our combinations, our combos. And then I want to do some recursion, right? So do recursion, and then in this recursion, I want to keep track of the combo we're at right now. So combo, or I'm gonna say cur actually. So cur and then the index we're at, mostly because the index will represent like at what value we're at, or what like number we're at. So we can tap into the values in the dictionary, right? Um, so um, first thing I want to do is I want to. Oh, it felt kind of weird. I felt like maybe I'm losing my teeth. But anyways, so we're in that first search where we want to do our base case. So the base case is that so once we find our answer, there's never a case where we don't find our answer. We'll always find our answer. So if index is equal to, or it can be just more than equal to, just to be safe, is more than equal to the length of digits, then it's safe to say that we have how can I word this? It's safe to say that we already what's the word? I can't think of the word right now. That we've already filled our combo. So basically I'm just gonna say like if combo done and add into res. So res out append and then just return or stop basically, stop recursion. But if that's not the case, then I want to go through I want to go through every value that I want to go through every letter that that number has to offer. So I'm going to say that number is equal to mapping at I don't want to do that. Number is equal to digits at index. So this is our key basically. Number is our key. Key to access mapping. And I want to go through every value that the number has so I can add it into the combo. So for I in the range of the length of the sublist. So mapping at number at I. I want to go through all values that the number has, through all letters the number has. I'm going to say combo plus equal to the letter, and then I want to go through that first search with that combo. So if we can go to the next, we can go to the next number in the list. So index plus one, or I mean the number in digits. Go to next number to add letters. That number. Um, and then I want to basically pop the end of that combo. Usually we just do like combo.pop if it was a list, but since this is a string, I'm going to do something Pythonic, which is just like combo is equal to combo minus one. So basically, I'm going to slice the end of the list off. Um, and then, yeah. And then from there, we can just call DFS with empty string, and then the next equal to 0, and then we're going to return res. So yeah, it's pretty much it. Um, what I'm going to do is I'm going to code this up, and then I'm going to kind of review like how the algorithm works, right? Uh, I kind of demonstrated how the algorithm works a little bit here, but I'm just going to restart, I guess. So okay. Well, other than that, let's just go ahead and go back to the code. So I know this definitely works, right? I should have done it in such a way where where I write the plan. I also draw out how it's gonna work out, but I should have done that first. But whatever. How long do we have? It's been 12 minutes. Oh, it's pretty fast, honestly. So I'm just gonna cut it out really quick. So I kind of cheated. Oops, kind of cheated already. But I know that the mapping's like this. So this is our mapping. I don't want to write all of that. It's gonna waste a lot of time, but this is fine also. So that means equal to this. So yeah, first step in our plan is to get the mapping, and then we're going to initialize a resulting list, and then we're going to do that for search. That's going to keep track of our combo and the index that we're at right now. And then for our base case, if our index, so if index, we're going to go to the length of our digits, then we're going to append the digit, we're going to append the combo in there, and then we're going to return. And then if that's not the case, then we still need to append the letters into our combo. So go through all possible letters. So append all possible letters into combo. So for I in range, oh, I also need to get the number. So number is equal to, let's name it num. Num is equal to digits at the index that we're at right now. So for in range, all the way up to the sublist length. So mapping and num, and then that's pretty much it. And then I want to add, so add the letter to combo. So I'm gonna say combo plus equal to the letter that we're on right now. So num, then add I because it's a sublist, right? So basically referencing these elements. And then um, go to next number, and add its combo of letters to current, no, to current combo. So I'm gonna call DFS with the combo, and then I'm going to say index plus equal to 1. And then so basically what we're doing here, it's a good way I'm doing it. So basically what we're doing here is we know that 2 starts with A. So first letter is gonna be A, right? And then once we go through A for the first time, I mean once we add A to the combo, we're going to go through the values of 3, right? So 3, it has D, and then once we're done with D, right? This is what we're going to append to the list, so AD. And then now we go back to up to A. Um, then we go through E, and then now AE is our string, which is more than equal to the length of our digits. So we append that to the list, and then we go with F. And then this is more than equal to the length of the digits, so we append AF to the list. And then now that we've gone through DFS with 3, we're going to return a 2. And 2 is like, okay, we're done with A, so let's go through B. And the cycle kind of repeats where we go through where we are at B right now, and then we have to go through 3. Then 3 has DEF, and then we're done with 3, so we go back to 2. With 2 already did one, we already did B, A, B, so we go to C. And it also has DEF for 3. All right, so that's what we're kind of doing. So that's kind of what we're doing. So we're getting the num at the index, digits at index, and then we're getting the mapping of that. I mean, we're getting the length of the sublist of it that contains the letters. And then for each letter, um, we're kind of adding it to a combo. So for example, we start off with an empty string. We want to add all the combos of 2 in there, all the values of 2 in there. So what we basically do is we do like append A, remove A, we're done with A, then go to B, we're done with B, then go to C, right? But actually in this code, what we're doing is we're adding A, we're adding A, we're adding A, then we have to go through B, because we have to get all the combos of B first before we go through, yeah. And then I mean, yeah. No, and we go to 2. It's kind of confusing the way that I'm saying it, because yeah. And then we pop, right? So to pop, we just say pop. So combo is equal to combo minus 1. And then we turn res, but then, oops. But then I have to call DFS with an empty string and then 0. So yeah, I just want to reiterate again. So we're getting all the values of 2, which is A, B, C, right? And then in the code, so like we added A, then we have to go through all the values of 3, which is D, E, F. So we say A, D, A, E, A, F. And then once we hit A, D, A, E, A, F, we kind of append it into the resulting list. We stop recursion. And so once we're done with 3, we go back to 2. We're not done with 2 because we still have A, B, C. Still have B, C, I mean. So what we do is we pop out A. You pop out A, then we go to B. Then do that all over again. We do this. We add the EF. Then we're done with B. So we pop B out. Then we go to C. then we go through three, right? We go through three, and then we add DEF. Then we're done with C. And then now that we're done with everything, now that we're done with everything, recursion should stop. Resulting list should be populated. And then yeah, it should be populated once we call that first search. And then then we're going to return our populated list. And so that should work. But if we run it, I know there's going to be a thing. Oops, that's a syntax issue. There's going to be a thing where, oops, I forgot to do length. It should work. Yeah, there should be a case where we output an empty string, but it expects an empty list instead. So what I have to say is, so if digits is more than 0, or length of digits, oops, to run that first search. But if not, then we won't run it. Then we should just return res right here. So this should run successfully, and then we should submit it, and it should be correct. So yeah, so the runtime is 2 to the n, 2 to the n, and then for space, I'm pretty sure it's also 2 to the n. No, space is I don't know what the space is for backtracking. I should research that, but I don't really care. So yeah.